Hey y'all, Kenny here. Thanks for joining me for part 3 of my Dreadnought guitar build. Before I get into how I bound this instrument, let me back up a minute and talk about the top. Don't feel like I addressed that as well as I should have in part 2. It is the most important part of the guitar as far as tone is concerned. I wish there was a formula I could give you so that you could judge the strength of your top, but I don't know how to do that. But I can give you some dimensions. This is Sitka spruce. I sanded this to a final thickness of 110 thousandths. That is a good average for a Sitka spruce top, plus or minus 10 thousandths. I also mentioned that I taper my top, meaning it's 110 thousandths at the bridge area, and it gradually tapers off to around 100 thousandths where the top joins the sides. I'll give you the dimensions of my braces as well. Some people say you can't build guitars by dimensions, but mass-produced guitars are built that way, and some of them sound pretty good. My X brace is 1/4 by 1/2. Some guitars use 5/16, even 3/8 by 1/2 inch bracing. I've experimented with the heavier bracing, but I prefer the lightly braced guitar. The brace is 1/2 inch at the intersection of the X, tapered to 3/8 of an inch at about the center of the bridge. Is carved down to about 1/4 of an inch in this area, up to 5/16, then it's tapered off to about 1/16 of an inch where it joins the sides. The upper half of the brace, again, 1/2 inch down to 3/8, and it's carved off to 1/16 of an inch where it joins the sides. If you use the 2 diagonal braces behind the bridge, which is a pretty common bracing pattern for a Dreadnought guitar, those braces will look like this, with this side matching this side. There are 2 of those. I use another X brace behind the bridge. It begins about the same thickness as my bridge plate, which is about 100 thousandths, rises to about 3/8, then is carved off to about 1/16 of an inch at the tail block. The other half of that X goes in this direction to stiffen the treble side. Again, about 3/8 at the intersection of the X, down to 1/4 up to 5/16, tapers off to about 1/16 of an inch where it meets the main X brace. There are 2 braces in this waist area. They are 1/4 by 1/4, and I carved them in this shape. You don't need much bracing at all in this area. The next support brace is 5/8 by 1/2. There's also a 1/8 inch thick strip by 3/4 of an inch wide to reinforce this neck area. So that gives you an example of my bracing. Again, if you over brace your guitar, you can always reach in through the sound hole after it's finished and lighten the bracing, so it's best to err to the strong side. This is the point in the construction of the guitar where I get a little anxious, especially when I route the binding channels. It is the area of the guitar where poor workmanship is most likely to be seen. I have made mistakes. I had a bit that worked loose in my Dremel tool once when I was routing a binding channel, but you take those mistakes, turn them into opportunities to do something different. And I'm not building cookie cutter guitars, so I just go where the project takes me. So before I cut my binding channels, I block sand my guitar. Use a solid block, not a rubber block. I use spray adhesive on a block that I've sanded flat to hold my paper. You want to knock down any high or low spots around your sides and around the edges of your back and your top, because your cutter is going to follow those high and low spots. The safest way to make your binding cuts is to score them first. That way you're not likely to pull a chip out of your back or sides or top. I made a tool to do that with. You can buy one. They're not very expensive. I use an X-Acto knife blade for the cutter, and I've ground it so it'll cut in either direction. I have a set screw that locks the blade in place, and I can adjust the depth of cut. I'm going to take that out so I don't have an accident on my top. Adjust the width of the cut by sliding this block along the tool. It's real easy to set up, it's real easy to use. You just set it on the side and drag it around the instrument, lay it on the top, drag it around the instrument, One thing you don't want to do is cut into the end grain, so you have to change directions around the instrument. For instance, you'll cut this way, and so on. Now you can do the whole job with this tool if you make multiple fine cuts and then use a sharp chisel to remove the wood that's left, the same way I do my rosette. My choice of power tools to cut my binding channels on my guitars has evolved over the years. I started out using a Dremel tool with this somewhat crude edge guide that I made. This has two problems. One, it's hard to set up. Two, the Dremel tool is just underpowered for the job. I now use my drill press, and I put my guitar in a carriage. I'll show you how that all works here in just a minute. But first, I wanted you to see this little router that I bought over at Harbor Freight for $30. It comes with an edge guide. I used it to cut my purfling channel in this guitar. It worked great for that. It has plenty of power to cut this binding channel. But the problem with cutting your binding channels with a router on a guitar is when you get to the back, this radius causes your bit to be at an angle to your sides. It's not square. Now, I've had an idea for some time, I've just never followed through on it. Take a piece of sandpaper, lay it on the back of my guitar, take a block of wood, sand that block of wood to the radius of the back, and then make a little adapter plate to go on the router. That way the bit would be square to the sides of the guitar. I may get around to that at some time and let you know how that works. This is the carriage that I use to hold my guitar as I cut the binding channels into the drill press. It has 4 screws. I use these to adjust the guitar so that the sides are square with the work surface. That way this cutter bit is always cutting square to the sides. Here we are in the carriage. These blocks hold the guitar secure. I've adjusted this so that the sides are square to the work surface. This is the router bit that I'm using. This bearing gives me a 60 thousandths cut, so I sand my bindings just over 60 thousandths. I've made this spool that has a bearing all held together by this stop collar. Beneath that bearing, there are shims that I can add or remove to adjust for the height of my bindings. This just rides along the top or the back and controls the depth of the cut. And this little bearing will control how much wood is removed from the sides. So this is what I've done. I've reduced the tension on my spindle return spring so that gravity causes the spindle to drop. I just sit this spool on top of the guitar, turn the drill press on, and I feed the instrument into the bit. As I do, the spindle will follow the contour of the guitar, and it gives me perfect binding channels every time. Before I glue my bindings on, I inspect the channels. If they need some work, I can touch them up with a sanding block. I always use wood bindings. These are curly maple. They're more work than plastic, but I think it's worth it. I always do a dry run first. I get the end joint to fit. Then I tape one piece on and cut it off at the center and square it up. Then tape the other piece on, and I'll leave it a bit long. I'll glue this side on first, then glue this side, then trim and fit this joint. I have the back bound. I use a lot of tape. I'm using Scotch contractor grade, pretty strong stuff. You know, my 5-year layoff from building the guitars caused me to forget a few important things. I normally bend my bindings in the side bender, and then I heat up my hot pipe and bend these back bindings to match this wedge-shaped profile. In my haste, I failed to do that this time, and getting these stiff maple bindings around this upper bout was a bit like trying to coax a monkey into a suitcase. But I prevailed, and I'm hoping it's going to turn out okay. I normally glue my binding and purfling on the top at the same time, but this wood that I cut from the sides to use for purfling has a lot of run out in the grain, and as I was bending it around this upper bout, I started hearing some cracking noises. So I'm gonna glue the purfling on first, that way I can support this piece of wood. Then I'll come back and clean that up and glue my bindings on. It's gonna be a little bit more work, but I think it's a safe way. It's better than getting into a mess that I can't get out of. I've leveled the bindings on the back and the purfling. To do that, I use a utility knife blade for the heavy work, razor blade for finer scraping. Sometimes the bindings will washboard as you're scraping them, and when that happens, you just sand them down smooth and you can scrape again. I'm using white glue, by the way, to install my bindings. A quick tip on removing the tape from the top of your guitar. I told you not to cut into the end grain when you're making cuts on the top. Likewise, you don't want to pull the tape toward the end grain. You run the risk of picking up a sliver of wood that sometimes will run all the way up the top. So you want to start at the center of the top, pull toward the sides. I also rotate my tape and pull it across the grain as I remove it. That also reduces that risk. You can use a heat gun to help soften the adhesive, and that will help as well. Let you have a look at my installed bindings. Really pleased with this end joint on both pieces. It's almost invisible. My purfling, a lot of work still to be done. A lot of sanding I got to do and fill the back and sides, get it ready to spray. And I'll be working on that off and on, but I'm going to focus mainly now on this neck and getting it set in the body and doing the final shaping on it, getting a fretboard on, and get ready to assemble this box and make some music. There are two ways to mount a neck in a guitar so that you get the correct bridge height. One is to mount the neck at an angle, which also requires that the top be slightly angled from this neck support brace to where the neck joins the guitar. The other method is to use a tapered fretboard. I think that method is probably easier for the beginning luthier, and I use that method just because I like it. Now, to ensure that you get a good fit between your neck and the body, you just insert sandpaper between the two and drag it through as many times as necessary to get rid of any gaps. So while you're doing that, you also need to keep a check on your neck angle. Not only that, you need to make sure that your neck is running straight with the instrument. I run a string from the center of the headstock down to the center of the top at the tail block and sight along that string to make sure my neck is straight. To help you understand neck angle, if I put a straight edge on this guitar, the neck is level with the top at the bridge position. So when I install my tapered fretboard, 1/16 of an inch, which is roughly what this binding is, that will put me at about 3/32 at the bridge position. I'm going to conclude part 3, even though I haven't accomplished everything that I wanted to. I did get a bit wordy in some of my explanations, but I started this video series with the first-time builder in mind. I'm self-taught. I built my first guitar before there was a YouTube, and I know it would have been helpful to me to have a simple explanation of some of the hows and whys of building an acoustic guitar, and hopefully I can help you as well. I did get my fretboard completed, and I'll visit that first thing in part 4. So if you like my content, give me a thumbs up. Subscribe to my channel so you can follow my progress. Again, thanks for watching, and I'll see you soon.